Hello ma'am, I'm Harish, 21BI1034. I'm here to present about Chomsky normal form for my DA3 presentation. So, what are normal forms? Normalization is performed in order to standardize the grammar. This is by reducing the grammar gets minimized but does not get standardized. This is because the origins of the productions have no specific format. In order to standardize the grammar, normalization is performed using normal forms. This is what we're gonna see in this lecture. So there are two types of normal forms. One is Chomsky normal form and one is Gravage normal form. In this video, we are gonna see about Chomsky normal form. These are the most frequently used normal forms, both of CNF and JNF. Now we are gonna see about CNF. So what is Chomsky normal form? The Chomsky normal form is a context-free grammar, which is said to be Chomsky normal form if all its productions are of the form A gives BC or A gives A, which is nothing but A comma B comma C can be non-terminals and small a b can be referred to as terminals. From this, I can say that in formal language, a context-free grammar is said to be Chomsky normal form, first described as Norm Chomsky. For all of its production rules are of the form A gives BC or A gives A or S gives epsilon, where A comma B comma C are non-terminal symbols and the letter A is terminal symbol, which is represents the constant values, and S is the starting symbol, and epsilon denotes the empty string. From this above definition, I can infer that to be in CNF, all the productions must derive either two non-terminals or one single terminal. CNF restricts the number of symbols on the right side of a production to be two. The two symbols must be non-terminals or a single terminal. We can see this example. Here, the given grammar, context-free grammar, is given as S gives AB and A gives A and B gives letter B. This context-free grammar is in Chomsky normal form. How can we convert this context-free grammar to Chomsky normal form? So we have set of steps that I have referred to as algorithms. In this following steps, we have followed to standardize the grammar using CNF. Rule number 1. To reduce the grammar completely by eliminating the epsilon productions. Number 2. Eliminating unit productions. And number 3. Eliminating useless productions. By using these three elimination process, we can convert CFG to more normalized Chomsky normal form along with some other processes. So, using this rule 2, we have to replace each production of the form A to B1, B2, B3 to until Bn, where n greater than 2, with A gives B1C, where C gives B2, B3, so on till Bn. We have to repeat this step for all the productions having more than two variables on our RHS. After the elimination process that is given in this rule 1, we have to check whether the derived eliminated form of the context-free grammar satisfies this equation. Otherwise, we have to introduce new variables and we repeat the steps. So, rule number 3. To replace each production of the form A gives to A comma B with A gives X comma B, we have to introduce a new variable X that gives the letter A. In this form, we can create, as we said, we can create either two non-terminals or single terminal, because in CNF there are only these two type of production rules is implicable. That's what we have to do in this tutorial. So yeah, we come to the rule 3. So we have replaced each production of the form A gives A come A and B with A gives X B, which is like non-terminal. We have to give the non-terminal symbol to a new variable symbol. So repeat the step for all the productions having the form A gives letter small a and B symbol. So here we come to a problem that we're gonna discuss in this section. So first of all, I have to convert this context-free grammar to CNF form. So let's go through the question that we have got here. So here I'm going to convert this grammar which gives S, gives out to A as A, and a non-terminal symbol A and symbol B, and the symbol A gives B and S. The symbol B gives B, a non-terminal letter B or E. And here is another interesting terminal. This gives S naught gives S. So let me show how to convert this given grammar to CNF or not. Okay. First of all, check whether the given grammar is in CFG or not. To check whether the given grammar in CFG. So first let me explain about CFG. What CFG stands for? CFG stands for the context-free grammar, which is a form of a formal grammar which is used to generate all possible patterns of strings in a given formal language. A context-free grammar can be defined by four tuples. G can be defined by V, T, P, S, where G is the grammar which consists of a set of the production rule that is used to generate the string of a language, and T is the final set of terminal symbol which is denoted by lowercase letters, and letter V is the final set of a non-terminal symbol. It is denoted by capital letters, and P is a set of production rules which is used for replacing non-terminal symbols and in a string with other terminals or non-terminal symbols, and S is starting symbol as we all know. So let me go. Do we can we define this as in VTPS? Yes. As of now, this grammar is satisfied that it is in CFG form. So let's go to the step 2. Yeah. First of all, we have to eliminate any useless symbols that has been in the given grammar. So let us go as of now. So we are using a generating symbols. We are going to find what are the generating symbols and non-generating symbols. So by this way, the non-generating symbols are useless symbols which we are not going to use in the production rule, and we are not going to use in our CNF form. So for generating symbols is given by the letter G, which we are going to take all the non-terminal symbols, which is a small a and small b, and the epsilon production that we're gonna have here. Yeah. So as of now, we have a, b, e, and using the production rule, b gives rise to e. We are going to add. Yeah. We're going to add b gives us to a, and g gives us to a, comma b, comma epsilon, comma b, comma a, with a gives to b, and a comma b comma epsilon comma b comma a comma s, where s gives us to a comma b. And yeah, so for us s naught is non-generating as it cannot give s, and it's not reachable. S naught is not reachable, so we are going to, this is a useless symbol because this s naught is not going to give any value to our production rule, so we are going to eliminate s naught. So this is the new production rule we got after we remove the useless symbol s naught, which is nothing but s gives rise to a is a, or a small letter a and b, and a gives rise to b or s, or b gives rise to b comma a. And let's go to the second elimination process, which is nothing but elimination of epsilon production. Yes, this is an interesting thing. Yeah, we are going to remove the epsilon production that has been here, which is nothing but we have to remove b gives epsilon and a gives epsilon. Yes. Why do we need to do this epsilon production? Because for when we need to convert to CNF, CNF doesn't allow this epsilon production, which allows only these two. We must have two terminals, two non-terminals, or a single term. So how can we check, how can we eliminate epsilon production? Which is nothing but wherever you see the epsilon production, you have to dot product itself with the suitable production rule. So as of now, we are going to remove b gives epsilon and a gives epsilon by just replicating itself the epsilon with its production. When we remove this B and A, we'll get a new production rule, which is nothing but S gives rise to ASA, AB, ASA, AS, and S, and A gives rise to B or S or B, B. And hence we completed our second elimination rule. So let's go to this third elimination rule. That's nothing but to remove our unit productions. So first we can see that S gives rise to S. This is not applicable to our SCNF because we should not have a singular form, a singular terminal symbol. So we are going to remove it. As S gives to S, we can remove it easily because this is not gonna note to any other symbols. So there's no change. So we're just going to remove S as it is. So let's go to A gives to B and A gives to S. These are a unit productions which we need to figure it out. Yeah. So for A gives to B, we are going to, as of say, B is going to remove, and B and S going to remove, and we are going to use it as B. So as B is going to remove, we are going to add this B gives to the non-terminal letter B to here, because we are not going to address it as a single terminal unit, and as such, like A gives us to S, because A defines B and S. So A defines S is nothing but ASA, AB, ASA, and AS, which is we are going to take it back to here, because in CNF we cannot have a single terminal unit. So we are going to replicate with its production. That's it. So the new production rule defined by the third elimination rule, which is nothing but S gives ASA, AB, and so on, like as you can see here. Yeah. And yeah, now we have to convert this to a CNF form. As we mentioned earlier, we are using these two rules to define the production rule. Here I have been introduced a new set of variable, which is nothing but A1. A1 gives to SA, because we can see in this production rule we can't have AB, and in this production we can't have AB, and all of the seems to be okay, and AS. So we are going to retreat this by giving out as A1 to SA, so that A1 can be in a form of CNF, which is A1 gives to SA, which is also in CNF form. This is we are going to address. Now we are going to do about AB. It's very much simple. We are going to use the rule number 3 that we have mentioned here. As we can see, this is in the form of A gives AB, right? We are going to introduce a new variable, which is here X, and which is here U. That's it. Now we can easily figure it out, and I think I figured it out some of the thing. Yes, B. So we are going to introduce a new variable A1. A1 gives SA and U gives A. This is from the rule 2 that we have shown before, and this is from the rule 3 we have shown before. Introducing these two variables, this whole CFG is now converted to CNF. Yes, and this is how we have to create our this is how we have to change the CFG to CNF. Thank you, ma'am.